Hi, this is a tutorial for the image processing. Before going into the detail of image processing works, I would like to introduce the environment of MATLAB to you. If you look into the first window, which is this one is the command window. You can see right over here. This is to evaluate variables. For example, if I create a variable a and a stores the value 5, so if I have to multiply a with 5 or a power 4, so all the evaluation is performed at this portion of the code of the MATLAB. Another portion of MATLAB is the workspace. You know that when I have created two variables, the first variable was the variable a. You can see the workspace has displayed the defined variable, and this is another variable which stores the result of the process which I have performed on variable a. This portion of contain the works the current folder. If I have some code and I'm going to store that code somewhere, like I'm going to save it over here. The name of this file is mat tutorial. Then if I write some code over here in this editor, this is the editor portion. If I write some code over here, like I'm going to write clear all variables from the workspace, close all the figure windows, and clear the screen. If I write these 3 lines and if I run the code, then there should be the command window. The current folder should contain the path of that folder, so I will have to change the folder. Now you can see that I have stored the code at this specific path in my computer. So when I run the code, all the workspace variable and command window has got clear. I can write these 3 lines in just, instead of writing them in 3 lines, I can write it in a single line. If I have to write some comment like this is the tutorial for the image processing, so I will write a single %sign and I am going to write that tutorial first. After that, the coding had start. When I will run the code, only this portion of the code will be executing. The commented line will not get executed, just it will be skipped by the compiler. Now I have to load some images, like this image 1 is with PNG format. If I want to load this image, I will create a variable. So the name of this variable is variable I, or I can also write simply that I am read image1.png, and I run this line of code. You can see, and I have run this line of code, which is line number 3. A variable has been created and the name of this variable is IM, and you can see it in the workspace. This is the name of the variable, and values. Value mean that the dimension and format of the variable. The dimension of this variable is 508 multiplied by 4 192. So there are 508 rows and 492 columns, and the data type is unsigned integer 8. You can see there is a red line over here. This red line tells me that the instruction has not been terminated, so I will use semicolon line. So this has been terminated. When we do not terminate any instruction of our code, then during the execution the command window will show the result of that line. If we terminate, the process will be performed, but the command window will not show the result. So when we write very complex programming algorithms, then it is advised that you should terminate each instruction so that the command window may not waste time to display the result, but the actual process may be performed without displaying it. The process will be performed quickly if we terminate all the instructions. Now when I have loaded this image into variable im, now I want to display this image. If I have to display an image of JPEG format, I'll just only write the name of that image at this position, and now you will see that I have loaded the image, and now I have also displayed that image. And you can see the dimension of the image is 477 rows and 500 columns. Since it is an RGB image, so there are 3 channels, R, G and B. If we have to identify the dimension of the image, I will write a variable. I will create a variable. The name of this variable is dimension of image. You can write whatever you like, and there is a command which is built-in command, size. So I will write size of variable im. Size of the size command will extract the actual dimension of this variable, which is actually a matrix. When I run this code, you will see that the variable dimension im contain the size of this variable. Okay, through this procedure we have identified that what is the dimension of the matrix. I will now terminate this statement, and I'm going to open a variable so that you may know that how the values of the image pixels are being stored in the variable. So I'm going to double click on this, and you can see that nothing has been displayed. If I open this one, and you will see that something had been displayed. In order to show you that how the pixels of the image are being stored, I would like to create a variable. Since there are 3 channels in this image, you can see over here that it has been written over here that the number of rows are 477, the number of columns are 500, and the number of channels are 3. So these are 3 channels, red, green and blue. So I am going to extract the first channel, which is a red channel. So imr is equal to the name of the variable where the image, the complete image, which is RGB image, is being stored, is im. So I am going to write im, and the input argument is colon, and then there is again column, and then there is 1. This statement tells me that I am going to consider all the rows element and or the columns element, and I'm going to only consider the first channel. So only the first channel of this RGB image will be extracted and that will be stored in IMR variable. I'm going to write this statement over here, and I'm going to write a comment over here: extract the red channel of the image. Now I'm going to run this code, and you will see this is the input image which I have loaded into MATLAB. This is a JPEG image. It has been stored in the variable im, and when I have written this statement, it has told me that the dimension of the image is 477 cross 500 cross 3, and after this line the red channel of the image has been extracted and it is stored over here. And you can see that these are the pixel values of the red portion of the image. You can see that most of the pixel are 255. The values of the variable are 255, and a few have some less values. So since the complete image is white at the border, while at the center there are some values which are red, so you can see that this portion is white and the RGB value of the white portion of the image is 255, 255 and 255 for red, green and blue respectively. Since this is the red channel, so the values of the matrix of the red channel at the border will be 255, while at the center some lower values will be there. So you can see over here. Now again I am going to extract the red, green and blue channel. I am going to extract the red, green and blue channel. I am going to create a section of the code. If I write double %, then this section of the code has been separated from the above one. So in this section I am just going to extract the red, green and blue channel of the image. Since the first channel represents the red color, so I have written over here the 1. Now over here I am going to write 2 because the second channel is of green values and the third channel is for blue values, so I am going to write 3 over here. Now when I run the code, you can see the result that the RGB channel values have been extracted. This is the R, G and B values. Since this is a single channel, so there is no any other value. Like in the original image IM, the dimension show that 3 values, which is for the rows, column and channel. Since there is only one channel here in the IMR, similarly in IMG and IMB variable there is just only one channel, so it is a two-dimensional matrix and you can see the values over here. I am going back to the editor and I am going to display the resultant. I'm going to show you each and every channel of the image. So before going to display each and every channel, I would like to create a figure command so that each image be displayed in a single figure window. So the original image will be displayed in figure 1 and then there will be another figure window within which I will display the red channel. So I am going to display the pixel intensity values of the red channel at the second figure. Within the third channel, I am going to display the pixel value of green channel, and in the figure window 4 I am going to display the resultant values of the blue channel. Now when I run the code, there will be 4 windows which will be displayed. This is the first, second, third and fourth. This is the blue channel, which I have already told in the code that figure 4 or the window number 4 will display the blue portion of the image. This is the green portion of the green channel of the input image, and this one is the red channel of the input image, and this is the original image in figure window 1. I can also display the images in a 2x2 matrix. For that, what I will do is I will have only one window, one figure window, and the one figure window will be divided into a 2x2 matrix, and within each section a single image will be displayed. So I will keep this portion of the code and I will remove the other windows. Instead of these command, I will write subplot, divide this figure window into a dimension of 2x2 and display the original image, this one, at the first position. Now I want to display the red channel at the second position of the 2x2 matrix of the figure window. I want to display the red channel at the second position. I am going to display the green channel at third position of the 2x2 window, and I am going to display the blue channel at fourth position. When I run this code, now you can see that the original image is at first position, this one is the second position, and it displays the red channel pixel values. It represents the green, and then the fourth one represents the blue channel value. Now I need some title so that everyone may know that what is this all about. I'm going to write a title over here. This is the original RGB image, and when I run the code, you can see on the top of the original JPEG image which I have loaded into MATLAB. Now the title show that what is the status of the image in this subplot position. I am going to display the title of the red channel of the image. The other one is the green channel, and the fourth one is the blue channel. Now when I run the code, you can see the original figure window, which was the first figure window. It has been divided into a matrix of dimension 2 rows, the first row and this is second row, and 2 columns. So you can see everywhere there has been written 2x2, these 2x2, and you can also see that every sub image of this figure window has a title above the image, So this is the original image, this is the red channel of the image, this is the green channel, and this is the blue channel. You can see that the pixel values at the border over here at these position are have a color of white. So the white color is represented with a value of 200, and the perfect white color is represented by the value 255, and the perfect black is represented with 0 pixel value. Now if I open the matrix of the blue channel, and if I open the matrix of the blue channel and I go and drag the cursor to this dimension position of the image, you will see there will be a very low values. Like I am going to open it and I am going to go to that portion. You can see the values of the intensity has reduced. It is not 255, but instead they are below 100. So these are not perfectly black color, but somehow we can say that the pixel intensity are near the black value, which is 0. Okay, now I'm going to show you the histogram of this blue channel, and you will see that how the pixel intensities are distributed within the blue channel. So I am going to create a new section, display the histogram of any channel in the image. So I am going to create a histogram. When I run the code, okay, I have committed a mistake because I have not defined that where the histogram should be displayed. So the problem has been occurred. You can see that instead of showing me the blue channel image, it has displayed the histogram over here. Now I will write figure 2 at this place so that the histogram might be displayed at different position. So now you can see the first window contains the original image, red, green and blue channel, while the second window, the second figure window, which is figure 2, it display me the histogram of the blue channel. Now we will compare the histogram. So this is the blue channel, and you can see that very at the center position the pixel intensities are black. So these are the black pixel intensities. That it tells us that very few pixels are almost 0 number of pixels have 0 intensity. These are the black colors, distribution of the black color, and you can see that around about 45 pixel value, the number of intensity, mostly intensity have been distributed with pixel intensity value around about 45, like 50 or something in 30 pixel value range. And these are the perfectly white portions. So you can see that there is a 255 with a very high amplitude. So it tells us that the number of white pixels are of that much amount. They are about 16,000 or something. And if I zoom this portion, I zoom this small portion, it tell me that the pixel value 39 has been repeated about 9,000 times. If I highlight it, you will see now that the pixel value 39 has been repeated in the image about 8,000 times. So this was about the histogram of the image. Now I will teach you that how you can convert the original image into grayscale. Conversion of image into grayscale. So there is a simple command. I am going to create a variable. This is a variable which will store the RGB to gray. Is a built-in function through which the original image, which is IM, this one, it will be converted into grayscale through this command RGB to gray. And now I'm going to run this code. And you can see that the image has been converted into gray. This is the image which has been converted into grayscale. I am going to show you the grayscale image in the third figure window. Gray. I'm going to change it into A so that no one might get confused. And I'm going to include a title. Gray image. Now you can see this one was the original image, red, green and blue channel of the image. The second figure window represents the histogram of the gray, histogram of the blue channel, and this is the third figure window which represents the gray image, which display the gray image. Now I am going to include another window, another figure window, which will display the histogram of the histogram of the gray image. And I am going to include a title for this. Histogram of the input of the gray image. I am going to run the code, and you can see that this is the fourth figure window which display the histogram of this gray image. You can see that most of the pixel intensities are at this place, around about 100 pixel intensity, and there is rarely a perfectly black color in the image, and there is perfectly white color present in the image through, you can see over here at this place. Now I would like to display you the actual intensity of the pixel at the gray image. You can see that these are the borders, so the pixel intensity is perfectly white, which is 255, while at the center you will see that some pixel intensity are around about 100, which represent the slightly gray black color, like these colors. Okay, one thing you should note one thing that should be keep in mind that these are the images which I have loaded previously into MATLAB file into the editor, the code of which is here in the editor. You should keep in mind that the .m file, this is the .m file. When I have saved this code, when I save this code and I give some title to this code, it is saved with an extension .m, so which represent the MATLAB code. So the MATLAB code has been stored over here. So you should note that the original image which I am going to load into MATLAB and the M file should be in the same folder. If both of them are not in the same folder, then you should define the path of the image, the complete path of the image, that where in my computer drive it has been stored. Otherwise the MATLAB code will not identify and it will never find the code. For example, if I shift this image into another folder, if I am going to shift this into another folder, which is this one, and now if I run the code, you can see that in the command window it has given me an error that the file name jpg example flower.jpg does not exist. So if such an error is being displayed in the command window, then you should not be worried about. You can also change the path. I have included the complete path up to that image, so now MATLAB will find this image wherever it has been stored. Now you can see that the MATLAB had identified the image. So you should keep in mind that either you should write the complete path of the image, or if you do not want to write the complete path, you just want to write the name of the image with extension, then at that stage the image should be in the same drive. Like the image should be in the same drive where the code is being stored. The code is within this .m file. So I will copy this image into the drive. Now you can write the transformed image into write an image into PC, write an image. Now I am going to write this image into some place in my computer. So I am going to write the gray image into this folder. You can see in this folder there is no any gray image. When I will write the write command, it will save the image into this drive. So I am going to write the im write command, and the name of the image is im gray. So I will write the name of the variable which stored the gray image, and now what name I want to give to the output image. So I am going to give the output underscore gray dot, what extension should I include? I am going to write jpg, and the extension is actually jpg. I do not remember that whether I should write jpg or jpeg, but I will run the code. If it give me an error, then I will remove the e. I think the code is properly executed. and you can see within the drive where the MATLAB code has been stored. Now you can see there is another image which is the output gray image. So this was for how you can write an image. After reading how you can write the image, there is also another command. Instead of using the IMShow, I can also use another command which is IMAGE image SC, and now you will see the detail of this command. It will display the image with scaled colors. So if I have to display the image with scaled colors, I'm going to create another section. In this section I am going to show image with scaled colored command, which is IMAGE SC. I'm going to create another window so that the previous figures may not be overwritten. Figure window 5. In this figure window 5 I'm going to display the input image, which is IM. Now when I run the code, you will see that within the fifth figure window, this is the fifth figure window, the image has been displayed with some scaled colors. The colors of the input image have been scaled. I'm going to display and compare the so this is the difference between I'm going to write them over here, and I will run this code. I will see both of them in different window. So you can see this is the result of IMShow, and this is the result of IMSC, scaled version of the input image. This is scaled version, this is the simplest command. Both of them are almost similar. There is also another command which is known as IMTool. In the sixth window, this is third figure window, the second figure window, this one is the sixth figure window. So this was the result of IMTool, and you can see with this tool you can see that the first two position, like X and Y, these two position will tell me the coordinate position of the pixel, and these other values will show the RGB values. Like if I want to find the RGB value of the pixel at this position, then at this position you can see the values on the bottom scale tells me that at this position tell me that what is the X, Y and RGB value. Look into this. The red value is 163, the green value is 38, and the blue value is 32, while the coordinates are 42 and 245. If I go and put the mouse at the completely white position, you can see below at the left bottom position, at the left bottom corner of the window, You can see that the coordinates and color value are 255, 255 and 255. Now through this image tool, you can crop the image by using this crop command, crop tool. So the image has been cropped. You can also measure the distance, like the distance of this pixel from this pixel to this pixel is 238.21. You can zoom and shrink the image, you can drag the image, you can drag whatever you like, whatever you want to do. So this is the image tool. I am going to close these figures in the background. You can see that many figures have been opened, so I will write close all. Close all the figure window have been closed. Now I am going to show you another command for the images, and this is image. Through this I can also display the input image. You can see the image has been displayed with another command, which is image. So there is no big difference between these commands. I am going to close all the figure window, and I am going to remove that one command. So up to this instant you have learned that how you can load an image of any extension like PNG, JPEG or whatever format is it. Up to this instant you have learned that how you will read that image. There is a simple command, imread command. You will have to write the name of the image and then you will have to write the extension. And if the image is stored in the same drive where the code is present, then you will have simply to write the name and extension of the image, and the image will be loaded into a variable. But if the image is present in another drive, then you will have to write the complete path. After that you will have learned that how you can identify or extract the dimension of the input image. Then after that you have learned that how you can display different images in different windows, in different figure windows. Simply you have to change the number over here, then the image will be shifted into that figure window. After that you have learned that how you can divide a figure window into a matrix. So I am using a 2x2 matrix to display the input image, which is the actual RGB image, and the green, blue and red, green, blue version of the input image. And you have learned that how you can write a title above the image. After that you have learned that how you can extract the red, green and blue segment or channel from the input image, and how you can write title about these channels when you display it in the command in the figure window. After that you have learned that how you can display the histogram of any image, if it is an RGB channel or whatever it is. After that you have learned that how you can convert an RGB image into grayscale, and then how you can display it, the histogram of the gray image. After that you have learned that how you can write an input image, whatever is stored in the input image, if it has been processed and has been converted into some other data type or whatever, how you can store that image into some drive in your computer. If I am going to store it in the same drive, then I will just write the name of that input image. If I want to store it in another drive, then I will write the complete path of the folder along with the name of the image, for which the name of the output image. Like I am going to store the processed gray image in the same drive with output gray, name, so I have written the name of the image. This is the extension. After that, I have told you, I have displayed and I have worked here that how you can display an image in with some few more commands. There are some tools through which you can modify the input image. Now I will tell you that how you can convert the input images. So this is for the image conversion. We can convert the input image into indexes. So how you can convert intensity image to index image. So for that purpose I am going to create a variable so that I may not have any problem. So I am going to convert the gray image which I have previously created into index, and the gray image was, I think, this one. This variable stored the gray image, so I am going to write over here this. When I run this code, we can see in the workspace right over here at this place an index index variable has been created. When I open it, it tells me that these are the index values of the pixel intensity. If you write help gray to end, you will see the description of this command, that what it's actually, it convert the intensity image into index image. We already know it. Now what is the gray to end scale, then round an intensity image to produce an equivalent index image. So these are the indexes which have been stored over here. Now after that there is another command through which we can convert the image into binary. Like black and white image. This is the variable which will store the binary image. So im to bw is a command which convert the input image, which is a color image. It will convert that image into binary. I'm going to write the gray image over here. This is a grayscale image with many pixel intensity value from 0 to 255, but when I write im to bw, it will convert the input image into a binary image. So I am going to display it in the 7th figure window. I am show image into binary. I'm going to write a title on this, binary image, and now when I run the code, you can see in the 7th figure window the original image, which was a colored image, which was a grayscale image. You can see in figure window 3, you can see this is the gray image. This gray image has been converted into black and white. The im to bw, this command used an automatic thresholding scheme, and the pixel intensity above a certain threshold are converted into 255, and the pixel intensity below a certain threshold value are converted into purely 0, and there is no any other gray intensity value in the input image, in the output image. So the binary image, if I display the binary image, you can see there are only ones and zeros. There is no any other pixel intensity in this image. Either the value of the pixel will be 0 or it will be 1. I can also convert the data type of the image from image to double precision. If I write IM2 double, you will see that the input gray image will be converted into a double data type. Now when I run the code and I display the workspace, so this was the original input image and this is the gray version of the input image, and you can see the data type of this gray version is unsigned integer 8, and you will like to see that pixel intensity value are of 8-bit and the value ranges from 0 to 255. Now when I have converted into double data type, you can see the data type has been transformed from unsigned integer 8 into double, and these are the values, and you can see the values are in decimal now, and these decimal values are being stored in within a range from 0 to 1. All these values are within range from 0 to 1. I can also convert it into unsigned integer 16 by writing unsigned integer 16. I can also convert into index, which I have previously performed. Now I will tell you some basic operation of the which we can perform on the image. Now I will resize. First I will resize the image. So there is a command the input image have been resized like by using the command to resize the input image, which is im resize the input image, which has been converted into grayscale, and the dimension of the grayscale image is this one. I want to resize and I want to switch into 50% of its rows and 50% of its column. And when I run the code within the workspace, you will see that this was the input image. When it has been transformed into grayscale, the dimension was 477 and number of column were 500. Now when I have resized, the number of column have switched from 500 to 250, and the number of rows have switched from 477 to 239. So this is the resize command. I can also convert this image into double of its size by writing 2 over here. Now you can see the input image has now the number of columns which is double the original, which is previously they were 500, now they are 1000. Similarly 477 is now 954. So you can resize the input image whatever size you like. I'm going to reduce it. We can also rotate the input image, like IMR is the input image which will be showing us that I'm going to rotate the input image, which is a gray image, and I'm going to rotate this input image by 45-degree angle, and then I am going to display the result of the rotated image. The result of the rotated image is this one. Image. So this is the rotated image. The image has been rotated by 45-degree angle. You can rotate it to whatever angle you like, but you should have to clearly mention the angle. I'm going to save this file, and I'm going to save the demo video. I will tell you in the next set of operation in the next coming video. Thank you so much.